just want to thank you. You've done an outstanding job with the instrument import.
Great. Thanks.
Oops, oh, yes, there we go. And good morning, Nick.
Morning.
Hi, Nick.
Hey.
Well, just to kick it off this morning, I just sort of want to spotlight some of the work Charles has done. So, you want to tell us about the import real quick, Charles, and then I can pull it up on the screen. But
yeah, so it's this pandas code that reads in a text file from this Shimadzu Nexera, and it just sort of cleans up the data and the column names and puts it into a readable pandas pandas data frame.
exactly. So, Nick, so essentially at the laboratories, when the data comes off the instrument, it essentially just looks like this. So this is what the scientific instrument is spitting out whenever you send in the test result. So here it's just may look like a bunch of gobbledygook at first, but you'll see, we've got CBDV, CBDA, CBGA. So this is what the instrument's actually measuring, and we're getting a lot of readings, but primarily what we're looking for in all of this mess is the concentration. So there's a lot of data, and we really just need one data point. Well, we need a couple data points, but so this is where data wranglers like Charles play a critical role. And so Charles has written this import method. So this import Nexera. And so essentially, all you have to do is point to that data file .text, and we now have that data in a slightly cleaner format. So we now have the compound, and so, for example, if you look at the last observation, well, it looks like there's a lot of columns, so let's iterate over this real quick. So,
did you want me to drop some of those columns?
Well, a principle that Craig Dempkin, Dr. Craig Dempkin, he's an economics professor at UNC Charlotte, he stressed to me, never throw away data. And I mean, to a certain extent, you need to clean up the data, but it's a good principle to keep in mind. And his observation is, especially when you start to take means and things, you start to lose some of the data, and you don't want to just be throwing away variables and portions of the data willy-nilly. So, as data storage becomes cheaper and cheaper, my philosophy is just archive everything. So just save it. So let's try to print out all these variables here, and then we can just talk about the things that are interesting. So I'm not 100% sure how we can iterate over just this one observation, but we can try a couple things here. Okay. So I kind of want to print out this whole thing, but it's a little long. I think okay, so now we can see, so this is essentially one observation. So this is one compound of one analysis of one sample. And so we've got all of these data points for this one compound. So 128 data points. So that's probably excessive. And as you see, a lot of these are just blank. But the things that you do need for certain, you need to know the compound. It helps the analyst and the software to know where the data is stored on the instrument. So this is the actual file path on the instrument. So scientific instruments are essentially wired up or wireless to the computer. And so the data is typically stored on that computer. So then you also want to know the sample name, the sample ID, but depending on the instrument. Then the sample type, if the analyst has entered it. The retention time. So just a brief, very brief So just a brief introduction to a chromatograph. So essentially, you're running the analysis on an HPLC or another scientific instrument that does chromatography. And so your, say, runtime may be maybe on a faster machine, maybe, or a faster instrument, maybe it could be as low as 4 to 7 minutes, but maybe, a typical would be 11 to 16 minutes per analysis for a single sample. And so your retention time would be about, so this would go to about 13 minutes. And essentially you're going to be passing little injections of the sample through the instrument, and if something's detected through chromatography, you'll get a response. And then the area of the peak represents the amount or the concentration of a particular substance in that injection. How do you know what type of substance it is? Well, that is the retention time. So here you're seeing the retention time of 6.323. So let's just conjecture that this is 6 minutes and 23 seconds. This is THC. And then what's been done is people have isolated THCA, and through repeated scientific studies, they've determined that given your parameters, THCA should elude, so that's when it comes off your column and creates this peak at around 6 minutes and 23 seconds. So you can calibrate your instrument to essentially label this peak automatically as THCA. So we've got that. And then the concentration, 49.445, is this area under the curve. And so that represents the concentration of THCA in the sample. Oh, that was injected through the instrument. So those are the main data points you're looking for. Of course, the chemists may be interested in some of the other variables. So for example, they may be interested in when the peak started and when the peak ended, because you want a nice uniform peak. You don't want lumpy peaks, so to speak. And a chemist could probably tell you a lot more about more of these variables than I. And so that's why I just resort back to the philosophy of never throw away data. And so may as well save it in case someone needs it in the future. So that's just sort of a quick scientific analysis just to give Charles props for turning this data, this text file, into a reasonable data frame that we can now do work with. So for example, we can find a particular sample. What was the variable's name again? And so with the click of a button, you now have all of the compounds for this method. It looks like there could have been 2 runs of this. So let's actually just find out all of our samples real quick. So this is the beauty. So we're just basically going to show what's so cool about the work Charles has done here. So because it's all of this data is in a data frame, we can make short work of it. So we can find the samples. Excellent. So say you were looking for a sample name QC Prep A. Well, now you have all of the cannabinoids that were analyzed. And you could take it from there, and so essentially this is a critical step in the data collection process, because I'll just let you know, when I started as a laboratory analyst, essentially until there was a good way to import this data, I was essentially just transcribing all of these concentrations by hand into the database. So as you could imagine, as you can imagine here, That's a so for each of these, I would be transcribing the concentration. So as you can see, it's easily quite a nightmare because you're having to do all of this crazy parsing and the number is just hidden right there. And then for one sample, you're having to do 11, so for in this case, 11 compounds. And so, 11 times 3, I mean, that's 33 data points you have to enter for 3 samples. Or you could use Charles' import method and just import all the data. It's ready to go. It's in a pandas data frame. And my philosophy with Python is if you can do it with a computer and you've got enough time and willpower and know-how, then you can do it with Python. So long story short, awesome work, Charles. Just phenomenal. So
Yeah, that's really cool.
and Charles has actually pushed this to the Canlytics engine. And so, Nick, this is sort of maybe something up your alley. So this is essentially an interface for cannabis analytics. So primarily started out geared towards laboratories, so importing data and getting it into the traceability system and getting certificates to clients. However, it needed a good interface for the traceability system. So I essentially wrote a wrapper around the metric API. And just to show you, it's nothing like fancy here. So I essentially modeled this off of GSpread. So this is just a random Python package that wraps around the Google Spreadsheets API. And I thought it was a good example of an API wrapper. So I modeled the metric API wrapper around GSpread. So it's got a similar structure, but essentially it just leverages requests to hit the metric API. To just sort of, so Nick, real quick question. As, say, a licensee in Oregon, are you allowed to use the metric API or do you have to go through a third-party vendor?
We can use metric.
Excellent. So hopefully this is a tool that you could just use right out of the box. So essentially you'd authorize your metric client. So this just creates an instance of this client here, and there's nothing really fancy going on. It's just a class, and it just keeps your credentials as a header. So it just creates a session, sets your vendor API key and user API key as the authorization, because I'm getting a sneaking suspicion that Metric may use Python as their backend for their API, because they may not, but some of the responses I get are, I'm not sure, just sort of the way it's structured and just the way it just plays so nicely with requests. I don't know. So it may not be, but it does play real nicely with requests. So all you have to do is set the authorization on your session with essentially, so this is essentially your username and password. So it's just sort of brilliantly simple. And then the client, you can interact with it in a couple ways. So you can either use the client to just, do all your workflow, or the client actually returns. So for example, like if you're working with employees, it'll actually return an employee model. And so if you want to sort of dig into the code, the models is a pretty informative place to begin. So the base model just sort of sets up a lot of cool functionality that integrates with Firebase, but essentially all of the metric models are represented here. So we've got an employee, we've got a facility. So the employee is a really simple model, just a full name, license. Then you've got the facilities. And then for example, this is how you're able to, to leverage a lot of the functionality straight from the model. So you've got facilities, you have locations, strains, items, plants. So just to give you an idea, we don't have to scroll through the whole thing, but harvests. So you have packages, patients. So patients is on a state-by-state basis. So I don't believe all states have patients. Nick, in Oregon, do you interact with like patients at all in the metric system, or is that just not really a requirement?
No, because we don't sell to patients, we sell to the retailer. So the retailer may, because we're on the manufacturing end. So
yes. All right.
So we don't, yeah.
So, but there's, and here are some interesting helpers for you. So there's lab results, and then there's transfers. So these models could really help you out. So just for example, to give you an idea about how you would actually use some of the code, you can actually check out the tests. So if you go to tests, traceability, metric test, this sort of walks through how you would actually use all of the endpoints, or at least the majority of the endpoints. So just sort of to walk you through this real quick, in case you're interested in using it. The way I would recommend, firing everything up is maybe, and you can have your own setup if you would like, but I would, I mean, you may have your API keys on your server, but in this case, I just have them in an environmental variable file, so a .n file. So you can just read in your credentials from the .n file, and then you get your vendor API key and your user API key one way or the other in a secure way. And then you can fire up a client. So you can name it whatever you want. I just call it track, just for a nice short namespace. And then once it's set up, you can get off to the races. So you can get your facilities. And the reason that's important is you'll want to know the license number of your facility. So this example you'll notice here we're creating locations, and you'll notice that I actually pass a license number here. So you can either pass a license number every time if you have multiple licensees or you have multiple licenses and you need that flexibility. Or if you just have a single license and you just want to simplify things, you can actually pass the client a primary exactly. So you can pass the client a primary license. So that way, that way you don't have to, that way you don't have to pass the license number every single time you're doing something. But in this example, I am passing the license number just to show you how you can use, say, a cultivator's workflow and maybe a retailer's workflow down below. So, long story short, you may want to check it out because you can initialize this metric client, and then you can do everything under the sun with metric. You can create your locations, update them, view them. You can manage your strains. So this is sort of how you go about creating strains. This is some functionality that may need to get worked into the actual client itself, may need to be implemented at some point, because essentially when you create, so here when you create a strain, in this case I'm creating the new old time moonshine, you're not return the ID, unfortunately. So you actually need to do a quick get call on the strains to actually get that new strain. And you'll notice that actually, I'm not certain if you can filter strains by time. You may or may not be able to. But similar things with items. So you can sort of use this test case as an example of how you would go about, creating items or just getting items if you're just, because before your manager gives you the green light just to start willy-nilly, well, you don't want to willy-nilly do anything, but before you get the green light to start posting, you can just start by just getting your inventory, right? So just get your items, get your batches, and then I guess you're a processor, so you may not have plants or harvests, but then you can get your packages. So these will be critical for you. So that way, you can just go ahead and get your packages, and that way you can get them into Python and start analysis. So, I'm sure you could put together some interesting. Yeah, I'm sure you could put together some interesting statistics that could impress your boss. But oh, and then finally, when you are ready to really ready to start with the workflow, then you can start doing transfers. So transfers are a little complex, and so I'm interested to see how this would work in production. And so if someone wants to start using the transfers in production, it'd be quite interesting to see and maybe see how we could optimize it. But transfers are a bit more complex in metric than they are in leaf data systems. But it's approachable. So essentially what's happening here with the transfer is you've got your shipper. And so that's, that's the person, of course, transporting it. Okay, so, and then you, of course, need your recipient, then information about their license, and then you of course, add all the packages. So there may need to be a bit more efficient way than just passing it a giant object, but at the moment, that's the way transfers are created. However, once they're created, because of the nice models we have here, you can, you can update the transfers, without much trouble. So, so this is sort of the tortoise and the hare philosophy where, it took a little bit of time, to write all those models, but now they sort of pay off, because especially the transfer ones. So basically, the majority of these classes have built-in functions to create, update, and delete. So almost all of the models, for the most part, have those three. So that way you can just create, update, and delete a model just from itself. Ah, yes. It was actually the client. So the client has some helper functions too to help out with transfers. So I wish I could print these out real quick, but okay, I'll start wrapping this up because, so long story short, there's a lot of utility functions you can use here to make your life easier. You can get transfer types. You can get you can get all the transporters. You can get a transporter's details. And then, of course, create, update, and delete transfer. So I just sort of wanted to just sort of show you that real quick, just to, just to sort of tell you about this tool, because it's here if you want to use it, and it's designed to be simple and easy. So ideally, you can just toss in your vendor API key and your user API key, and you're off to the races. So, like I said, it still needs to be hammered a bit in production, so that way we can figure out all of the interesting utility functions that can be added to it to make everybody's lives easier. but it does function. It does successfully hit all of the endpoints. So it works. So may as well put it out there and, see if anybody can find it useful. So I guess before we move on, are there any quick questions about the metric interface?
No, you've done some really good work.
Thanks. And like I said, it was inspired by G-Spread, so really from start to finish. So I mean, so just to kind of show you some of the similarity here. So, see, they just have their client, their model, their URLs, exceptions, and some utility functions. And metric, same thing. I've got the client, some exceptions. So just to handle the, the base metric errors that are thrown. And then, oh yes, and then the URLs. And so when you initialize the client, actually, sort of not shown in the demo, but you'll want to pass it your state. So the state is actually by default Oklahoma, because that was just where Canlytics was verified first. However, so when you initialize your client, when you initialize your client, you'll want to essentially use this snippet here. Because the one in the example is sort of this simple, like the most minimal case where you just pass the vendor API key and the user API key. You'll probably also want to pass, you'll definitely want to pass the state equals to OR, lowercase. And then you may want to pass the primary license if you're just thinking you're going to just work with one license. So, nothing fancy there. Just all the URLs, and then there's a handful of utility functions, which these are just sort of things that sort of suit my fancy. For example, just my preference for snake case. So a lot of the package. So basically metric, a lot of their fields are camel case. And I have a hard time reading camel case. I can read snake case faster. And so I just turn everything to snake case. So if that's not preferred, just leave some feedback. But I don't know. I feel like it makes things simpler. And then it's all brought together here.
So the user has to go in and sort of manually change all those fields, or is there like a setup utility with like a user interface where you like walk them through what they need to set up?
Ooh, good question, Charles. So essentially, this is designed to maybe be plugged up to a user interface. So this is more of an API. So this is a wrapper around the API. So this is essentially like a programming interface to the API. So just to basically make the API easier to use through Python. But if you were essentially designing a user interface, you would you would still currently need to essentially pass some of these parameters. So here, actually, the test case is a good example. So in the user interface, you'll need to collect, certain variables. So just to sort of show you. So for example, for locations. So here, to create a location, you need well, the locations I've sort of tried to make a bit more efficient. The locations, you only need to pass a name and then it'll create that. So the locations is actually a bit more efficient. But the strains, for example, at the moment, this object is essentially what you'll want to pass from your user interface. So in your user interface, you essentially need some way for the user to enter the name, the testing status, THC level, CBD level, indica percentage, and sativa percentage. The models actually have a from method. So for any model, so you could, for example, you could essentially do strain dot create from JSON, and you'd pass it the client, your license number, and the object. And then this object can be in camel case or snake case. But still, once again, you're still needing to pass it the object. So to answer your question, Charles, you still need to get this object from somewhere. So from my experience, just if you could boil the user interface down to just passing JSON objects, then it makes it quite pluggable. Because so now anyone can make any sort of user interface, right? You could use you could use any JavaScript framework you wanted. You could use, yeah, exactly. So you could use Flutter, so there's some other alternatives, but essentially any JavaScript framework. And you'll just basically have a form where you just have the user enter their name and then these other fields. And then you would just pass your JSON object. And then here in your code, in your Python code, you basically just get your strain, and then you can just pass that strain to your client. So why even do this? Well, it's basically just so you don't have to one second, let me just navigate. It's basically it's just supposed to be just a nice shortcut around having to do this every time. So basically, the benefits to the client are it creates a session. So that way you've got essentially this open, you've got like a connection established between your piece of software and metric. So that way your requests, can go as fast as possible. And then it essentially just wraps a bunch of helper functions around the request, because basically you're not doing anything fancy here. You're making just a request. So it's a bit complex, but you're basically just making a request. So that let's open it over. What were we just looking at? Okay, the client. Okay, so the requests. Okay, so this request is not really that much different than essentially just saying import requests. So essentially you're just doing import requests, requests dot get, your URL. Basically just doing that, and then you may pass it some parameters. And so your parameters, that's where you actually can pass filters. And so that would so like, for example, a metric one, I think they've got like something like last modified. Right. You want to double check this. Anyways, but I wonder if in my test case, we may try some of these filters out. I may need to write some test cases for the actual filters, but essentially, you're doing that, and then you're saying, so this is essentially would be like the simplest way to make a request to the metric API. You would basically get your endpoint. Like if you were just like trying to get started right out of the box, that's essential. You wouldn't even pass it parameters. So and that would, yes. And so that would essentially give you your response. So this would basically be, your simplest request to the metric API. And then, your data would be, your response.json. But this, with like, less than 10 lines of code, I mean, honestly, about 5 lines of code, really. Yeah, so with like 5 lines of code, you can make a request to the metric API, and there's nothing wrong with that. And in fact, that's an awesome way to go when you're getting started. When you're, you're actually, setting up your user interface, you're going to maybe find you're going to be repeating some things. So for example, some try and accepts. So here, this is sort of restarting the session if the session ends. And then down here, we're checking the response, because when you get, and next week, I want to get the green light that I can actually show you the test environment in action. So I actually want to check with Metric if I can actually demo the test environment or not. I'm not certain I can. So that's why I'm just showing you the code for today. But next week, I would love to show you this in action, so to speak. But I just want to get the green light first. Then I may not. But long story short is, real quick, like, you can just get the response. You can check its status code. So that'll raise an error if you didn't have a 200 status code. But essentially, this is sort of just how the client grew. Basically, you start with just this simple import requests. But I just sort of knew that this was just going to be, just a simple wrapper around an API. So you're just going to need some basic things like, a session just to be efficient, and some try accepts. And so that way you just have this built-in exception class. And it's just basically, I copied this from GSpread, but it's basically just a fancy way to get the error message. So basically, when metric errors out, they may give you different types of error responses. And so this is just a fancy way to handle all the cases. So that way you can get a nice error message printed out no matter what the error is. And then it just, returns models. So that way the models are an attempt to be sort of self-sufficient. They're not entirely, but you can think of the models as souped up dictionaries. So they're basically just dictionaries that they also have a couple built-in methods. So they basically can self-update and self-delete. So that's the main thing. And just from a programming point of view, it can be useful because, so this is still a long answer to your question, Charles. But basically, in your user interface, you've got your form where you create the strain. This is done on your back end, where you basically just get the strain's ID and save it in your database. And then on the user interface, if say you then change one of the form fields, well, then you just run this function on your back end, and it just updates the strain. And then if they like click the delete button, you could say they called the delete button, you could just do, oh, we want to do, you can basically just self-delete these things. So the long story short is it's primarily meant to be used, programmatically. So whether you plug this package up to your user interface, or you just want to, just write some scripts and you just need a helper. I've just found creating abstractions quite useful, because let's take it all back to the ground floor here in the end. Because what are we trying to do? We're trying to make your workflow as simple as possible. So we just looked under the hood, and so don't be scared or anything. Just look at GSpread. I pretty much just copied the work there, and it ended up being a little complex, but it's as far as wrappers go, it's not the most complex wrapper in the world. I tried to keep it as simple as possible. And then I've just found that creating wrappers helps in your workflow, because then you can abstract away all that complexity. So this is actually a programming philosophy that I've learned recently, is you want to program to an interface. So this is an interface to metric. So we're basically, all we're doing is saying get plants, manicure, harvest, move, get packages, get receipts. So there's no logic here. That's our interface. And then this is what's called our implementation. And so this is where we've actually implemented our request to the metric API. And so our interface doesn't care about our implementation. So it's brilliant, because you can set up your user interface facing code, so that way you just call in get packages. But let's say get packages needs to be improved or refactored. Well, you just go and you can fix or improve the implementation of get packages. But then everybody who's using get packages, so say you're using the Canlytics module, then you don't have to change anything. You're good to go. You can update to the next version, and everything just still keeps working, So we can, if we need to fix some error so here we're doing some error catching, in case, basically this catches it in case, does it return a list? Does it return an object, or does it return nothing at all? And so, say we need to add error catching to create packages later. Well, we can change the implementation, and then the interface stays the same. So that's sort of a design pattern that I've learned recently, and it's been incredibly effective. It just makes writing software a dream. And next week I may show you the Canlytics console, which is actually trying to do what I just described, which is take this engine, which is an interface, a programming interface to the metric API, so an API to an API. But next week, I'm going to try to show you how I've plugged it up to the Canlytics console, so that way users actually can enter in their strains and everything. So next week, perhaps, I can show you how, instead of doing strain creation and management or package creation and management programmatically, we can basically wire this up to a user interface, any user interface. So you can make any HTML, JavaScript, Flutter, Dart, Android, iOS, anything, right? Well, those may not be running Python, but you can plug this up to any user interface. Well, in this case, you would just be making requests, but plug it up to any user interface, and you're off to the races. So I just thought I would share that with you today. I know we were going to talk about statistics, so we may have to get back to that next week, because I also have some really cool data that Charles has put together on waste analytics. But I think we're out of time for today, so I can show you more of Charles's awesome work next week. So just to wrap up today, are there any final questions, comments, thoughts, or anything?
No. I do need to go back and fix a couple of things in that import code, or at least make it more efficient.
Yes, and that's where you've hit on the important principle of refactoring, where, that's the way software goes. Think about how far computers have come. You basically just need to start somewhere. So you just need to start with some code that works, right? So you wrote some code that imports that laboratory data. So awesome work, Charles. And so, as you noted, it can get tidied up. It can become more efficient, and it can gradually be improved. And that's what you always have to be doing to your code, is just keep improving it, keep refactoring it, and that's how code evolves over time. And so, but you have to start somewhere, and so thank you for making those contributions. And so Analytics now has its first contributor. So thank you, Charles. And we're excited to really, this is really speeding up. So it's really exciting. And yeah, it's exciting to put these tools out to try to be helpful. And we can all tinker on it. So if you're open to it, I may actually maybe adjust some of your comments and things just to sort of fit sort of the style of the project. But I think the code looks good and functions good. So if you want to tinker on it anymore, then by all means. But I just want to really thank you, Charles, because that is a huge contribution. And like I said, that's one of the most valuable things for laboratories, is to be able to get that data and import it into the laboratory's database with the click of a button. No data entry, click a button, all that data is in your system, ready to go. Let your analysts spend time doing science, not doing data entry.
Yeah.
Quite amazing. So thank you for contributing to Canalytics, Charles.
Sure.
Great. Well, we've run a little long, so I'm going to go ahead and wrap it up here. Just so I don't keep you all day. But thank you for coming and checking out the latest developments on cannabis data science.
Yeah.
All right, crew.
Thank you.
Till next
Have a good
week.
day.
All right, and then feel free to reach out through email or messages if you have any thoughts, or Nick, if you start to use it and you run into any questions or anything, just reach out, because I want to get this tool in your hands so you can find some use for it.
Yeah, we'll do.
All right, awesome. All right, everyone, until next week.
Okay, bye.
Have an awesome one.